We are on to the second session in the decision makers track for this morning. We've been off to a fantastic start so far already. We've been talking about sort of defining, looking a deeper look at observability through the panel discussion. We just came back from looking at how do you adopt open telemetry within the organization with Adriana in this track. And now we're going to take that a step further. What does sort of improving your telemetry data for better observability look like? So we'll give it another, maybe a couple more minutes before we get started. And then I'll hand it over to Iris to enlighten us on this amazing topic.
Hello, everyone.
Hey. By the way, where are you joining us from, Iris, today?
I'm from Porto, Portugal. Very sunny and beautiful day here.
Thankfully, it is here as well. So I'm joining you from Durham, North Carolina, which I think for folks who've heard me so far would know as well, which is it's nice and sunny out here today. Porto is definitely one of my favorite places. In fact, Lisbon and Porto probably come up as two of my favorite places in the world at this point, honestly. I'm a big fan of the Porto wine as well. The nice sweet reds over there, which is fantastic. Yeah, I love the weather as well. So I've been there a couple of times, which is great. Hopefully someday soon we'll be back.
That is amazing to hear. I'm not Portuguese. I've moved here a few years ago, but I feel the pride when someone says, oh, these good things about Portugal, because it is indeed a great country.
Indeed. All right, folks, without further ado, because we are on a slightly tight timing for this conference overall, we want to give you enough time for breaks and enough time for questions. So without further ado, hello and welcome, everyone. Thank you so much for joining us for the second session in the Decision Makers track for LEAP 2024. So far, we've been exploring, trying to define what observability looks like, looking at a deeper look at what that looks like in practice. We just looked at how adoption of open telemetry could work, 3 steps that Adriana mentioned in the previous talk just before this. And right now, we're going to be exploring how can you improve your telemetry data for better observability by Iris. So I'm going to hand this over to you, Iris, a quick introduction, and then take it away.
Hello, everyone. My name is Iris Dyrmishi, but it can be Iris, it can be Iris. It's a pretty international name, so wherever you are from, just pronounce it as you prefer. I am talking to you from Portugal today. I am a senior observability engineer at Miro, and today I'm going to talk about how to improve your telemetry data for better observability. I've been working in the area of observability for almost 4 years now, and it is a fascinating area to be right now, with so much movement and improvements and everything going towards open telemetry. It is really an exciting time, and I'm happy to see that there are so many people interested in this area now. So what I want to talk about, improving your telemetry data for better observability, always comes to one point, always. Observability, when it's seen, it always has the highest bill in a company. And it's always, oh, the observability team is spending so much money. So that's something that us observability engineers see it and hear it every day, but deep down we know that this is not just us spending the money, it is a shared load. But of course, in order for you to have a mature observability system, it's good to spend money, of course, because data needs to be processed, needs to be saved, needs to be collected. It has its own cost, but you need to be smart with it. So my question is, how do you do observability in your own companies? Do you just throw money at it and collect everything and just try to get as much information there as possible? Or do you constantly improve your telemetry data quality? Something that I've noticed is that the improvement of data comes with a lot of experience and a lot of maturity in observability systems. Because of course, there are companies that are just starting with their observability journeys. They have bigger problems, but then you have companies that have been for a while there, and you see that they're getting to the point that they really want to do this improvement, not just for the cost. Cost is one of the factors, but the other factor is the experience of the engineers as well, because observability teams, we are service providers, so we need to provide the best for our engineers. And also for the company, obviously, to have the best experience with observability. So I am a big fan of quality against quantity. Of course, there are people that would say that I'm completely wrong, but the way that I see it, if you have quality data, you reduce MTTR because you do not have a bunch of junk lying around, things that are really not needed. And when your engineer is having an alert or needs to respond to an incident, they have to look really hard to find significant data. Of course, again, lower cost. It's one of the trends in the companies right now and in the tech world in general, keeping costs optimized while having the best features out there. You also have higher visibility. Again, it is interconnected with a reduced MTTR because again, you want to have the data that you need as much as you need, but you don't want any of the unnecessary things or information that you will never use that will just cause an obstacle for you when you're actually in a hurry. Imagine waking up at 2 a.m. in the morning, you are an on-call engineer, and you're trying to find this important information. The dashboards are not built properly. You have metrics with the same name, 10, and you don't know which one is yours and how it is supposed to work. And yeah, that can be terrible. Another good point of collecting quality data is better correlations. Many companies are striving towards going through better correlations right now. We have three important pillars in observability, which is logging, which is the oldest one, let's say, metrics, and traces. So for a long time, these three pillars were kept separate. So now it is time that we are actually taking a better approach. How about we correlate them, especially traces and logging? How much information that would give us. But of course, you cannot do that with just simple having some metrics, having some log and some traces and try to put them together by timestamp. It will not work like that. That's why it is important that your data has necessary information. So in the following slides, I'm going to go a little bit more in depth in some things that I have noticed as an observability engineer. And of course, I'd like to know your opinions if you have suffered is a big word, but if you have had these issues in your companies, or if you have any other issues, or if you don't agree with me, because of course we all have different experiences. So I'd love to hear all the feedback. This is the observability. We're always learning and improving. So the first and most important part about improving your telemetry data, and I always say it, I'm a big advocate of it, is that observability should be a team sport. It is the human factor. I see a lot of observability systems that are built by a singular team. You have an observability team. They know very well what they're doing. They're very well, but they're the one instrumenting the code. They're the one creating the alerting. They're the one creating the dashboards, and the teams are just using that. For me, that is a completely wrong approach. I was actually listening to Adriana's talk before, and I completely agree with her. The engineers that are building their applications know their applications best. So they should be full owners of their telemetry signals, alerts, dashboards. They should be the ones setting them up. Because at the end of the day, when the phone rings in the middle of the night and they need to go and check what is happening, it's going to be them and not us. Me as an observability engineer, I'm very good with infrastructure, but if you throw me in a Java application and I have to debug it and troubleshoot and create meaningful alerts for it, I'll probably not do a good job. I'll have some default things that, of course, you can provide, but it's not going to be any good. So it's very, very important that the team should be aware of the data they're sending. They should create their own things, and of course, have the proper guidance of an observability team that is showing best practices, giving this, let's say, these tools to instrument to create alerting and dashboards. And another important factor as well is a company-wide awareness about observability costs. Again, we go back to costs because it's one of the most important things right now. If everyone is sending whatever they need, it is okay to accumulate costs. And imagine that you are in a scenario that every engineering team is the owner of what they're sending. So of course they say, oh, this metrics, I need all of them. These logs, I need all of them. I'm going to stay on debug logs 24/7. I'm going to just keep sending traces, accumulating costs that at the end of the day, only 10% of that information will be useful to them. And that is fine because, okay, I have to rephrase. It is not fine, but it is okay if they have not been given proper instructions or how to do that. And that's why I believe that having FinOps together with observability is one of the best moves that can be done in a company, because teams need to be aware of the costs. Once they see that how much everything that they're sending is cost, they will try to be smarter about what they're sending, what they're consuming. And at this time, we also reduce the amount of data that we're sending, and we send better ones, because we're always striving to make what we send significant. So that is a very important part of being an observability engineer, to be an advocate for all these practices. So moving from the human factor, I will start with my favorite pillar. It's tracing. I always think that the tracing is the forgotten child always, because in the company, it's always the least developed one, or the one that we don't pay attention to. But tracing has so much capabilities and so much potential. So we just need to build it better. We just need to invest some more time on it and to understand it better. So some of the things that I've seen about tracing that could potentially cause issues, or that make people or engineers not interested in it, is that there is not enough information on the spans. So immediately it's like the spans are not good, so data quality of tracing has decreased. So what would if I said that there is something that is even better than logging? Maybe the logging enthusiast will come after me. But for example, one of the improvements that you can do to your tracing data is that you can add span events. It's some sort of description that will tell you what exactly happened. So therefore, you will not even need correlation with logging. You will have that information there immediately. Another thing that you can do is that you can enrich spans with custom attributes. If you are using some sort of legacy instrumentation or some custom one, but you really needed some extra information to provide some correlation with logging, you can easily do that. I will take the example of Open Telemetry Collector here, which is the most used tool currently, and what I'm used to doing all these changes. And it's very easy to provide some custom attributes, whatever you need or you think that this is necessary, because that's the beauty of observability. I am here talking about it, but I don't know the specifics of your companies, of your setups. You as observability engineers, software engineers, you know best what is needed. So if you want to have a span attribute about the cluster, add it. If you want to have, even if it's tea, coffee, whatever you need, it's possible to do it. Just make it meaningful. So when you actually need this information, it is there for you, and it is available and according to your liking. But of course, don't forget that it needs to be uniform as well, because observability, it's everyone is an owner, but there has to be some sort of standard and format that you need to follow according to the guidelines of your observability engineers. Or if you are an observability engineer, keep that in mind. Everything needs to be standard. Otherwise, it's going to be all over the place. So another thing I see with tracing, it's very interesting, is so many companies have issues with tracing because they're collecting 100% of sampling. And imagine that it is millions and millions of spans, and of course, their platform cannot handle that. It is so expensive. Going through all the spans on a big trace, it is impossible, it is very slow, and it is understandable because it will require a significant cost to have a fast performing and well-performing tracing platform with 100% sampling with thousands of applications. So that being said, in this 100%, you also see, if you scroll through them, you could see some spans that really have no significance. For example, one that I've seen, I just am using it as an example now, is a /monitoring/ping, that it sends a ping to the monitoring. And that's it. It doesn't provide any other information. Do we really need to save that? No. For example, we see other useless spans that could clog the tracing platforms that are absolutely not necessary. So what can we do about that? Well, one simple solution is a tail sampling. I am a big fan of this tool, and I will tell you how it works right now. So instead of you saving everything and then having to manually go through and query and find the trace and maybe get lucky or not, and face this slow querying because of how much information there is out there, or maybe get confused by the amount of information. I don't know what is yours. How about you use tail sampling? It is associated with the OpenTelemetry collector. I'm a big fan, so I will mention it several times. It's for me, it's very crucial in OpenTelemetry, in observability right now. So the sampling is done at the end of the trace. After you collect the whole trace with all the spans in it, you apply some policies to it. You can set custom policies on which spans to keep or drop. And it's not, for example, oh, I want to keep 10%. That is probabilistic, and it was available before and still is if you that's what you want. And these custom policies can be added based on attributes, latency, whatever you prefer. They're extremely flexible. It can be probabilistic. You don't have to exclude that. Sometimes it's good that you have a certain amount of spans. For example, if you're using architecture diagrams, it's very important to have spans coming from everywhere, so you have a good idea of what is being built. And of course, sampling policies can be composite by combining several policies together. And I was thinking of a good policy, and I came up with this. Of course, this is all documented properly in the OpenTelemetry pages. There's an amazing community behind all this that could answer other questions. There are articles written about it. But for example, what you could do, and I find it fascinating that not many people know about it or implement it. For example, a great strategy is, what do we need telemetry signals mostly, is to identify when errors happen. So first thing we do, we keep all the error messages, the status code errors. What else we do? We know that we have service A and B, and we would like to have some general spans from them. So we get an information because we want to build architecture diagrams that are offered, for example, in Grafana Tempo. So you add a probabilistic on top of that as well. So you're basically saving all the spans with error status code and 10% randomly generated, not randomly generated, but randomly selected spans. And then you can go even further. You say, okay, I have another service, which is service C. And I want all the spans that have a latency over 5 seconds in service C. And there you go. You make it a composite policy. And let's say maybe 80% of the spans that you were saving before will not be there anymore. So you will now have very concise information about what you need. And when you have an incident, or you want to see what is wrong with your application, or you want to see the health, you can go there and immediately see what is wrong and what is not, without having to scroll endlessly for hours until you find the important information. I know that there are querying available in all the tracing backends, but it can be difficult. Trust me, it can be difficult to troubleshoot, especially if you are under the pressure of time. So the other pillar, I'm going to go for metrics, is my second favorite one. I don't know if it is allowed, but I, as an observability engineer, I have favorites as well. So it was tracing, now I go to metrics. And the biggest issue that we see with metric data that a lot of engineers report is that there is high cardinality. So some of the ways that we could improve the quality of this data is by having constant evaluations of cardinality in your metrics. I know that there are some cardinality exporters in Prometheus. You could create alerting based on that. You could create dashboards. For example, in Victoria Metrics, it is a built-in feature that you can see the cardinality of every metric and the labeling and how many instances of it there are. So it really depends on your setup and how much time you want to dedicate to it. For example, APM vendors also have this feature that you send all the metrics to them, and then they will see what is being used or not, or what has high cardinality, and we will give you a report and you will make decisions based on it, basically. Of course, part of these evaluations would be to identify the metrics with high cardinality and evaluate the needs of certain labels. For example, we have some metrics and you have an instance label and it has 700 instances, but the information that you're getting is nothing related to these instances. It is just some label that was added because someone saw in the internet that this how this metric should be done. it happens. It's not a problem. So it is our job to evaluate this and to see if we need to drop them or not. If, of course, you're using open source, it's going to be a bit more challenge for the team to do this, but it's not impossible. For example, you have tools like Mimir, which is the first in the picture that I'm showing, Victoria Matrix, Imprometheus. There are tons of ways to do that and to do the evaluation. Again, I go to the human factor because engineering teams should be involved in the whole process. They're the ones that are creating the telemetry signals in the first place, but they should be the one involved in this whole process of cleaning up, dropping. You cannot just go and drop something for them and they're not aware of what is happening. No, because they're the owners of it. They should be aware. Even better, they should be the one doing it with our guidelines. So it is very important, especially in big companies. It's not easy to have changes like this. So it's very important to have cooperation with engineering teams, good communication, good guidelines, and have them involved as much as possible. Another issue with metrics is that, is it supposed to be a metric in the first place? Sometimes we put some information out there that it is not supposed to be a metric. Maybe it could be a log. Maybe it's not even necessary. Maybe it could be better if it's a tracing. So these evaluations and these challenges are normal. Our mission is not to have things as they are and then just build tools on top of them. No, our mission is to challenge all these things that we see and to improve them. And of course, depending on the company and how complex the architecture is, it can be different for everyone. But it's good to have this mindset. Let's challenge everything to improve the things, because there are books about observability. There are articles about observability, but there is no straight way of, oh, you have to do observability that way. There are only guidelines that you can fit according to your needs. Sorry. So another problem about metrics, the metrics volume. We can have a lot of metrics, millions and millions of time series. It accumulates costs, and you go, for example, my tool of choice for querying is Grafana. If you go to Grafana and you search for CPU, and you see like so many metrics, or you see that it is being evaluated very often. There are so many metrics, and you say, do we really need all this? So the first question that I ask myself is, do you really need to scrape the targets every 15 seconds? Maybe yes, maybe no, but it's always good to have these questions, to ask these questions. Will 30 seconds work best? Maybe 60. I know that a lot of observability companies right now that are APM vendors are using 60 seconds as the main one. Maybe we can go in the middle. Will it affect our alerting? Will it affect our performance? Maybe, or maybe not. Maybe it's a perfect thing for you. This way, you have less time series to save and to process. And this way, your system is performing better. You are saving a lot, and your engineers are happier because when they're running their queries, they don't have to wait a few seconds to get the information they need. Of course, are the metrics being used? It's part of those checks that we need to do. They can be automatic, they can be manual, depending on the maturity of each company. It is what it is. Do we have the same label with different naming? It happens a lot. It's nothing that hasn't been seen. That, for example, if you want to add a new metric, you are adding cluster, let's say, for example, for a Kubernetes cluster, and somewhere else automatically it's being added K8S cluster, and somewhere else something else, and you see that you have the same label for different values. So this thing is good to be uniform, to be cleaned up, and this way you are saving a lot of money and improving a lot the quality of data, because alerts can be built based on this labeling, dashboards can be built, and it's just not uniform and not recommended. For example, something that you could do to improve this quality of data is to introduce instrumentation libraries. The OTA libraries are the best right now, and it is a uniform way. But of course, you can always introduce your own if you are not interested in OpenTelemetry. The important thing is uniformity, and for all the applications to have this uniformity and to be in a wide scale in the company. The other problem is, I mentioned this again, but yeah, sometimes it's difficult. Are they having issues? Are your teams going to Grafana, to Thanos, to check some metrics and they cannot find them? Again, the same thing. We make them uniform. We also enrich them with significant labels. Maybe they don't have the labels. They're being sent their custom metrics. They're being sent by applications, and they need to know from which instance they're coming. We are the ones that can do that. We can enrich this labeling. And yeah, we can do that again, just like with tracing. We can do it with Open Telemetry Collector, but I'm sure it can be done with other tools, for example, like Thanos, Victoria Metrics. Sky's the limit. if you want to find a way in observability, there are so many tools right now. Okay, moving from metrics, another problem.
It's just a quick one. We're about 5 minutes remaining, so I'm just giving you a bit of a heads up on that. Yeah?
Okay. Yeah, I'm almost done actually. So let's move to logs. The biggest problem that I've seen as an observability engineer, I use logs, but I prefer to use tracing and metrics mostly for my investigations. One thing that I've seen is a lot of mapping explosions. There are some big logging platform, because logging is the oldest pillar that was used. Everyone uses logging. If you go to a company, everyone will use logging, but maybe not metrics. Sorry, 2 seconds. So you go and you say, okay, what is happening? Why cannot I cannot filter or query my logs? And you see that there is huge mapping explosions. Why? Because the lack of uniformity is making so every application is imposing their own rules. So naming, they start with name. In another application, it is capital N. In another one, it is naming. Somewhere it's written grammatically wrong. And when you are trying to search for information, it is impossible because of these different things, and it takes you forever to figure it out. So unless you've been in the company for a very long time and you don't know these tips and tricks, you will have a lot of issues here. So what is a good solution? Of course, it is uniformity. Hotel logging is great. It is a great format that you can implement and impose in a certain way to the engineering teams. But you can also have your custom format logging. It's nothing. There's nothing wrong with that, as long as it is widely accepted. And you know that once you go, if you're using, for example, Kibana, once you go to Kibana and you search for a field, it always has the same name. That's a rule of thumb for me. Another big issue that we see with the logging is that you see a lot of debug logs active 24/7. Maybe sometimes they're needed, but imagine you are in the middle of an incident, you're trying to find information and the queries are slow. You see a lot of debug from another application, and you really need to skim through everything to find what is important from you. So how you can improve this information, this data? Maybe a good idea would be to implement policies that will drop debug logs after a certain amount of time. In a perfect world, it doesn't make sense to me that an application need to have debugging log 24/7 active. Yes, if you're having an incident for a few hours and then you just move to warn, for example, or even to error, depending on your team policies. But yeah. It really depends on case by case, but it is good to introduce teams with the costs of the logging. For me, this is the most important one, because logging is also forgotten, the debug logs, the trace context. So it's good, again, to have that relationship with FinOps and observability, that we know what we're sending. We have visibility and we do better and improve that. Another thing in the logs data is PII. I know, yeah, it's something that shouldn't happen, but it happens. It happens everywhere, because sometimes teams are not familiar enough with logging. Sometimes they don't know what they're sending. So it is our job as observability engineers to identify and to go straight to the root of the problem. You can impose filters. You can add filters on top of your hotel collector to drop all this data, but there's always something that will slip the cracks. So the best strategy is to go to the teams, tell them, hey, there's PII data, this is a security violation. Please make sure that it doesn't go again. And of course, the teams If as long as they're owners of their own data, they have to take care of that. It's kind of an obligation in every company. If you really need the PII data and logging, you can have isolated solutions for audit logs, PII, security, but they need to be very isolated, so not everyone can go and check what is happening there. So these are things that can be fixed easily. You just need to identify and to try to make the change. I'm almost done. So other cool features to improve your observability data. The first one is span-to-metrics. It's something really cool that I invite you to read about it. I have personally tried it in Grafana Tempo, and you can get metrics about latency, calls, how many calls are done, and size, which is very nice to have. In my previous company, we also took very good use for our Jenkins pipeline, so this could be a great case for you as well. Another one, architecture diagrams. Since you have the span information, why not have some architecture diagrams out there, and you are able to see better your applications with a simple query. And another one is auto-instrumentation during application runtime. Adriana also might have mentioned in her talk. It is a great tool that observability teams are doing right now, and open telemetry teams, that you can just instrument your application during runtime. You don't need to make code changes. And this is perfect, especially for teams that don't want to make a lot of code changes or that have sensitive applications. So yeah, keep this in mind next time. For your telemetry data, it is very important to have good data, to have good observability experience for you, for your engineers, but also for the company and also for the costs. So yeah, I hope this presentation was useful. You can reach out to me on LinkedIn, and you can find my LinkedIn on the website or on the agenda. Thank you so much.
Fantastic, Iris. Thank you so much for that. I know we are over time, but there is one question that has come up from Ruchir, which I would love to address over here. So Ruchir mentions, brilliant, Iris, 100% agree that organization-wide cost visibility is important. Also love your perspective on tail sampling, but aren't tail sampling policies more individualistic, which means engineer one can disagree with engineer two on what's important to keep and also how to deal with stale policies over a period of time. So a couple of minutes on these, if you could.
Yeah, I agree. They can be very generalistic. So I actually have a way of dealing with that. So first of all, I think that we should go through a first layer of this sampling policies. The first one should be by us observability engineers. We recognize some patterns. We know some things. For example, how much we should collect. It's really dependent on the observability engineers and the strategies they have done, cost-wise, but also the information that our platform is willing to support, because there is a limitation for everything. The second one, what I have noticed is that it is possible that after having this first layer of sampling, you could have your own one. Something that happens with these policies right now is that depending on the attributes like service name, you can have a custom policy. All you have to do is add that policy and then maybe add a label on your application. So as long as you have this label in your application, this policy is going to be added. But again, I say that this is up to the teams, but there should be some sort of limitations as well, because I could argue with an engineer that they need 100, they would say that they will need 100% sampling, and I could argue with them that they do not, because we have these great tools. So I think that first it needs to go through this layer of observability engineers, deciding some, of course, general policies there, and then looking at the corner cases, like the individual policies.
Fantastic. Thank you so much, Iris. This has been a great session. I think it's a good follow-up in terms of what you were thinking. There's some sort of logs, metrics, horror stories that you brought out as well, which is obviously definitely important to keep in mind. So thank you once again. And absolutely, optimizing cost as a way to optimize what data and what you're collecting is a really important point, because sometimes that can go out of hand. So with that, we come to the end of the session. Right now, we are heading over to 2 parallel sessions as we've been doing so far. On the implementers track, there will be open telemetry resources, what they are, why you need them, and why they are awesome. That is going to get moderated by Sonia, and Michelle is going to be the one delivering it. And then on our track, which is the decision makers track, we'll be opening up a panel discussion about designing observable API platforms. So if you were part of the first panel discussion that kicked us off, this is going to be sort of a continuation of that, specifically in the platform engineering world. So I'll see you there in about 5 minutes time. Thank you so much for joining this. See you soon. Bye-bye.
Everyone.